So, we've gone through the naming convention worksheet. We've gone through 2.0, so this is actually the first turn-in case where you're expected to list the identities, or at least understand some of the identities. Let's go ahead and get started. So this one's a little bit more, it looks a little bit more complicated because what we have are two sets of parallel lines. But like I mentioned earlier, as long as you know what your parallel lines are and you know what your transversal is, the lines themselves and the angles all have the same relationship with one another. So let's start out, name two supplementary angles. Now, without numbers, identifying supplementary angles that are not next to one another is incredibly difficult. So instead, I'm going to take advantage of the fact that a linear pair is also a supplementary angle. And I'm just going to pick two angles that when you add them up equal 180. So ABC, this angle here, and CBD, this angle here. When you add both of their angle measurements up, it equals a straight line, which is 180 degrees. Therefore, they are complementary. They are supplementary, excuse me. All right. Name two vertical angles. Now remember, a vertical angle is an angle that is formed by two lines intersecting, and they are the angles that share a vertex but don't share any sides. So I'm going to go back again to angle ABC, this one here, but I need to find the angle that it shares a vertex, so that would be point B, but it doesn't share, doesn't share a side. So it can't be CBD because it shares a side with it. So it's going to have to be DBH. So these are a set of vertical lines. There are a bunch that you can choose from. Those are just the first two that ran into my mind, so that's what I'm going for. All right. Number three, name two complementary angles. Well, this one's on me. I forgot to include anything that could possibly be considered complementary. So in this drawing, in this case, there are no complementary angles. Sorry, I'll get it right the next time. I was writing it with terminology in mind, not with drawing in mind. So anyway, there aren't any. So off we go. Name two congruent angles. These are angles that have the same interior angle measurement. Well, this is where we start to get a little bit, this is where things start to get a little bit complicated, because now we're getting into the theory of geometry. We're getting into, we're basically going to get into the theory of geometry. Exterior, so if you have congruent angles, it means that they have the same measurement. It means that they have the same approximate measurement. And so what I'm going to do is I'm going to point out what two parallel lines I'm looking at, and I'm going to point out the transversal that I'm going to point to. The two parallel lines that I'm going to look at are going to be CJ and EL. So I'm looking at the two parallel lines that are going diagonally up. For their transversal, I'm going to look at line AF. Because all you need to get these angles right is you need two parallel lines, which I got, and you need one line getting through both of them. So congruent angles, if you have if you have two parallel lines that are cut with a transversal, the corresponding angles of that arrangement are going to be congruent. So ABC is going to be the same as BDE. And if you think about it, you have two parallel lines. They're both completely straight. They're both going in a very specific direction. Then you have a transversal, which is going completely straight, but intersects both of them. The thing about parallel lines is the only way that they're going to intersect is if they superimpose on each other perfectly. But if you think of a parallel line as basically one line, and then you take a superimposition and you just separate it out, they're both going in the same direction. They're not going to intersect. But because they're both going in the same direction, they also intersect with the transversal to the same angle measurement, to the same separation. So these two angles are going to be congruent. The vertical angles are also going to be congruent. These two are going to be congruent because they're vertical, but they're also going to be congruent to these two. So hopefully now that you see some of these identities and some of these characteristics, if you have two parallel lines and a single transversal, there are a lot of things that you can learn. There are a lot of things that you can know about their relationship. So in this case, a congruent pair will be the corresponding angles of a transversal across a parallel line. All right, name two adjacent angles. And this one isn't really too rough, just pick any two that are right next to each other. So ABC, CBD, they're adjacent to one another. Again, if you have a linear pair and you know it's a linear pair, they're going to be adjacent to one another also. Name a linear pair. Well, here we go. I'm going to go back to ABC and CBD because if I take the two angles together, or I could say ABC and CBF, if I take the angle measurements, put them together, I'm basically taking the entire angle measurement for line AF, which is 180 degrees. So that adds up to a linear pair. All right, name two alternate interior angles. So what this means is you have to know which parallel lines you're looking at, and you have to know which traversal you're looking at. And then you pick an angle, and then the alternate interior angle can only have like one option. And so it's a whole decision tree of things that you have to pick if you're going to name something an alternate interior angle. So I'm going to go, my parallel lines are going to be AF and GM. So these are going to be my parallel lines. And I'm going to pick for my transversal CJ. So I've got these two parallel lines, I've got CJ. And for the alternate interior lines, I'm going to pick this small one here, which is going to be angle DBH, so DBH. Then I'm going to pick for the alternate interior angles to DBH is going to be GHB. So again, if I'm going to pick DBH, the alternate interior angle to DBH is going to be GHB. Now here's the cool part too. If you have two parallel lines and a transversal, their alternate interior angles are going to be congruent. That's another congruency. Alternate interior angles are going to be congruent with one another. Again, you have to start out with parallel lines, and you have to have a single transversal that's completely straight, but alternate interior lines are also going to be congruent. So, name two alternate exterior angles. Again, I'm going to stick with my original. Parallel lines of AF, GM, and I'm going to use the traversal EL just to kind of shake things up. And I have to pick two alternate exterior angles. So they're going to be on opposite sides of the transversal, and they're going to be outside of the space in the parallel lines. So I'm going to pick this one because this is my transversal. This is the angle I'm choosing that's outside of the space in the parallel lines. So that means, do this to make it a little bit neater. The alternate exterior angle to this angle here, to HKL, is going to be EDF. Now, as I'm sure you've guessed because of my notation, I've got something else I got to tell you. Alternate exterior angles are congruent with one another also. So this is the same angle measurement as this. And I know that because these are two parallel lines separated by a single transversal. All right. Next, I'm going to name two corresponding angles. This probably isn't going to surprise you, but corresponding angles are congruent too. Unless I already mentioned that, I get the rules kind of fall apart here. So I'm going to clean this up a little bit here. Again, I'm going to define for my corresponding angles the parallel lines AF and GM. So I'm going to work with my east-west parallel lines, and I'm going to go again with traversal EL. So the corresponding line, basically what you're doing with the corresponding lines is you're looking at the one parallel line with the transversal, and you're saying what angle do I want to pick? Which direction do I want to go? I'm going to say northwest, just for relative ease, which is going to be angle EDB. I'm going to pick this one here, this angle here. Well, the corresponding angle is the angle that has the exact same position on the other parallel line. And so the corresponding angle is going to be this one. And probably not going to surprise you at this point, these two are congruent. These two are the same measurement. But again, it's only relative to these parallel lines and this, and this transversal. All right. So now we're going to name two consecutive interior angles. So again, I'm going to pick my east-west parallel lines, and I'm going to focus on EL, the transversal, because I think that's framed up better in the camera. Name two consecutive interior angles. Well, because they're interior angles, we know that they're inside the space of the parallel line. And so if I pick this one, the consecutive interior angle is going to be this one. Now, for those more astute of you, so first of all, consecutive interior means they're on the same side. They're on the same side of the traversal. Interior means they're within the parallel lines. Consecutive interior lines are not equal. They are not congruent. They are not the same. But if you add them together, they're supplementary. So yeah, they're not a linear pair, but they are supplementary. So angle BDK plus angle HKD is going to equal 180 degrees. That's another pretty useful identity to have. And we're listing them now, but when we start doing actual algebra problems where we're trying to work out what these line angle measurements are, these are going to be pretty handy to have. All right, two consecutive external angles. Again, they're going to be angles that are going to be on the same side because they're consecutive, same side of the traversal, but because they're exterior, they're going to be outside the parallel space. So I'm going to pick this one again, angle BDE, and before I get started, I've got to name my parallel lines. I'm going to do the east-west parallel lines again, AF and GM, and I'm going to use the traversal, obviously, of EL. So consecutive exterior angles. I'm going to choose BDE, so it's going to be this angle here, and I have to do exterior, so it's outside the parallel lines, but consecutive, so it's on the same side of the traversal. So it's this one. Guess what? Those add up to 180. Again, you have to have the parallel lines, you have to have the individual transversal, but these two add up to 180. Pretty handy to know. Got a bunch of relationships here that it seems like you're not going to remember all of them, but you do a couple of problems and it kind of burns into your mind pretty quickly. Name a transversal and two parallel lines that intersects. I probably should have moved this question up to the very beginning, to one of the first parts, but I'm going to say parallel lines AF and GM and transversal EL. So there we go. All right, now with this one, we actually get to do some numbers. We actually get to do some figuring. So angle CBD, okay, CBD is equal to 6y minus 5. Angle DBH is equal to 4y, so DBH is equal to 4y. And angle FDK is equal to 2x minus 12. So FDK is equal to 2x minus 12. And we're solving for x and y. All right, well, what do we know about, what do we know? What I'm going to do is I'm going to say that my parallel lines are going to be EL and CJ. The reason I'm doing that is because and the transversal is going to be AF. The reason I'm saying that is because all of the angles are pretty much centered around this area here. So I know that these two are going to, so if it's up here, then if it's up here, it's following this line. So this is probably going to be your transversal. And if that's your transversal, then these two have to be your different angles. So what do we know? I know that CBD and line DBH, I know that they're a linear pair because we add them up and that gets us 180. So what that means is 6y minus 5 plus 4y equals 180. See what I mean? How if you know the identities and you know some of the features of what happens when you have parallel lines in a transversal, what that means. So now I can say that 6y minus 5 plus 4y is going to equal 180, which is going to be equal to line CJ. So now all I have to do is solve for y. So that gives me 10y, which is, 6y plus 4y, because the negative sign isn't effective, equals 185. That's a terrible 5, I realize it. So 10y equals 185. So I get 6y plus 4y, and then I'm going to add 5 to both sides to get rid of that minus 5. That gives me 10y equals 185. So y equals 18.5. I probably should have done this ahead of time, but I was just so happy that I had numbers for the example that I just kind of ran along with it. Now, why does that matter? Now that I know what y is, I know what 4y is. But the thing is, I still need to solve for x. But the thing is, x is in an angle that's a corresponding angle to this. So 4 times y equals 2x minus 12. I hope that's showing up. So 4y is a corresponding angle to 2x minus 12. Because again, CJ and EL are my parallel lines. The transversal is AF. So these 4y, so these two angles, DBH and FDK, are corresponding angles. Because they're corresponding angles of parallel lines in a transversal, you know they're equal. You know they're congruent. So I can just set this up and then okay. Just take my word for it. 4y equals 740. And now I'm going to solve through for x. So 752 equals 2x. And I'll solve through x equals, you know what? There we go. But that's the thing. I was able to find x and y because I knew all of these different angles. I knew what the angles were, and I knew what the measurements were. And that's the thing. I didn't actually know I take that back. I had no idea what the measurements were. I just knew that these two were the parallel lines. This was the transversal. And I immediately knew what I could set equal to one another. I knew what I could add to get another number. I knew how I could just use these different ideas in order to solve for whatever the problem was asking for. So we got another one. Okay, angle GHJ, all right. GHJ equals 4y minus 10. Angle KHJ equals 10x, so KHJ equals 10x. Angle HKD, all right, equals 9x plus 12. Okay, and I have to solve for x and y. All right, I'm going to clean this up a little bit because it's the last problem of the worksheet, and I'm trying to do these videos in order to make things easier to follow. I know now that my two parallel lines are going to be JC and LE. I know that, and I know also that the transversal is going to be GM. So what I'm going to do, I'm just going to clean this up a bit so it's easier to visualize. Okay, so all I did was I just cleaned it up to help visualize the relationships. So what do we know? I know that 4y minus 10 plus 10x equals 180. But that doesn't really help me out with anything because that gives me two variables in a solution. I can't eliminate one variable yet. But I do know that 9x plus 12 is going to equal 10x. Why? Because they're alternate interior angles. Again, EL and CJ are going to be my parallel lines. If they are my parallel lines, that means GM is the transversal. Inside the parallel space, this interior angle equals this interior angle. So that means 9x plus 12 equals 10x. All right. Solve through the algebra pretty quickly. That gives me x equals 12. Because I subtract 9x for both sides, gives me x equals 12. All right, now that I've got 12, now that I know what x is, now I can go back to this original one and try to work this out. Now I still know that this plus this equals 180, but that doesn't really help because I've still got two variables, except I don't. I only have one variable because I already know that x equals 12. So 10 times x is going to equal 120. Now what you're going to find, especially with these drawings, all right, I took these numbers off another drawing and I was like, I hope they work out. Obviously it doesn't work out in this case, but the important thing is that we can solve, we're using the definitions of the angles and we're using the definitions of the angles and we're using the relationships of the angles in order to prove mathematical relationships. The numbers aren't necessarily working out, but the way that we're solving them is the correct way to go. So now I know 120, so now I know this angle is 120, let's just say it's 120. But this means that I now have 4y minus 10. That's going to equal 180 minus 120. So again, because I know that this angle and this angle added together equal 180, I'm going to take 120 from 180, and that means that this angle measurement is going to be, it doesn't look like it, but this angle measurement is going to be equal to 60. So now what that means is 4y equals 70, and I am not doing the math on that. And there you go. Again, the drawings are they're going to do the drawings with the worksheets and some of the textbook examples that I'm going to use. They're a lot closer. Like I said, I just kind of wanted numbers to get the practice in, to get the identities in. But this is how you would solve a problem. You would realize, okay, these two, you would say, hey, these two have the same variable and they're alternate interior angles. That means that they're congruent. So that means 9x plus 12 equals 10x. So then I can solve for x. Now that I have x, I can plug it in, and now I can solve for y. And so that's how a lot of these algebraic problems are going to be for this unit. you're going to be given like one angle measurement, and then you're going to be expected to find all the other angle measurements in a particular drawing. It'll make more sense than this one, but some of the drawings are going to be pretty intense. Some of them are going to be pretty tricky, but the more problems you do, the more relationships you stay aware of, the easier the problems will become over time, and the more fun it is to solve things through with information that you have.